Hi guys, Math 3, welcome back from Easter. A couple of you were out today. We're going to check out some rational expressions. First thing we recognize immediately is we just want to make sure we know what rational is. We look at the entire page and we notice that every single one of these are fractions. So that's really the simplest thing for you to talk about, is that a rational expression is talking about something with a fraction. So we're going to follow all our fraction rules. These first three are just review from years past and things that we've done. If I asked you to simplify 8 over 12, you would find the GCF of those, and you would recognize that you can divide both of those by 4. Now, you wouldn't necessarily write your work like this, but once upon a time you did, and we can cross out those 4's, and we know the answer is 2/3. So the GCF of 8 and 12 is 4. So if I factor those out, I can cross out those factors that are alike. I can do the same thing here. We know rules for this. If I write all this out, I can write that out like this, and you recognize you have common factors on the top and the bottom of that too. You've also got common factors of x's. You can cross those out, and you're left with 2x over 3. All right? Again, we've gone through these in years past in Math 1 and Math 2. On this one, I can find a GCF. All right? And recognize that once you know that GCF is 5, you can actually cancel out the common factor. So what that tells us is, what we were trying to say anyways, is that if we want to factor the numerator and the denominator to find the common factors, that's what we're looking to do. All right? After you factor them, you're going to want to eliminate that common factor. That's the whole idea. So on this example here, we're going to factor the numerator. And the numerator factors into this two binomials. And then we recognize that these two are the same. So I can cross out those common factors, and I'm left with x plus 3. All right, x plus 3 there. I can look here and do the same thing on this next one. I'm going to factor out the denominator this time. And I just used my factoring skills from earlier in the year. And this time I recognize that I've got an x minus 7 and an x minus 7. I can get rid of those. And I'm left with 1 over x plus 2. Notice the 1 does stay up in the numerator and the x plus 2 in the denominator. Okay. This last example here, a little bit more complicated, but I recognize there's a GCF on the first one, on the numerator. And then there's also a GCF in the denominator. So the first things first, I always take out those GCFs. After I do the GCFs, I recognize I can still factor these a little bit further, so I do that. And in the bottom, same thing, that one will factor a little bit further. And at this point, I hope you recognize there's a lot of things that can eliminate. I can eliminate the x minus 3's, and I can eliminate the 2x's, and then the 6 of course reduces. And that leaves me with 1 times x plus 1. Of course, I don't really need that x plus 1, or the 1, so I get rid of it. And this is what we're looking at. Now, you have a choice to write your answer either way. I prefer this method because it's in a fully factored form, but recognize on a final exam it might be in either way for multiple choice. All right, one more at the bottom, or 3 more at the bottom. You'll notice that they're the same exact 3 problems. Okay. This time the question is, for what values are the following undefined? We need to remember right here that a denominator can never equal 0. A denominator can never equal 0. So if I look at all of these, I have denominators. I need to identify that this denominator here, x plus 2, cannot be equal to 0. So if I just solve that, it tells me quickly that x can never be negative 2. X can never be negative 2 here. Now, if I wanted to simplify this, I've already done that. We just did that problem, so you know the answer to that already. But that answer is only valid whenever x is not equal to negative 2. Same thing for this next one. I know that a denominator can never equal 0, so this denominator cannot be equal to 0, so I'm going to factor that denominator and say it's not equal to 0. Now, we've already done this problem. Remember, we factored it up here. And at this point, I set each of those equal to 0, or not equal to 0, I should say. Find out that x cannot be 7, and it cannot be negative 2. Last example, again, remember, it cannot be equal to 0, so this denominator cannot be equal to 0. Now, we've already factored this, so I'm just going to jump to the factored form. And that gives me 3 different things that cannot be 0. So you can see that each of those 3 cannot be equal to 0, and if I solve them each individually, I recognize what values make this function undefined. Now, we did some graphing on the calculator to recognize what this looks like, and we can go over that in class. Guys, if you got any questions, let me know, and your homework is to finish those problems on the other side.